Hi and welcome. In this tutorial, we're going to talk about cache, the cache feature that's provided by Hibernate. Earlier, I mentioned that Hibernate is much more than an ORM tool. Hibernate was started with the ORM problem in mind, and it was started as a solution for ORM. But as as features got added, there were a lot of other features that Hibernate implemented, and it became much more than an ORM tool. And one of the important features that Hibernate provides is caching. uh, there are multiple ways in which we can implement caching, and just like with anything else in Hibernate, it's configurable. But actually, what's happening is there is a level of cache that Hibernate provides for us by default without even doing anything, and that is called as the first level of cache, and that's implemented by the session object. So we've already seen that when you say you update an object that's in a persistent state, and you update it again, it does not actually result in two different update queries. It doesn't necessarily result in two different update queries. Hibernate intelligently detects what is the minimum number of queries that need to be run, and based on that it triggers the update query. So it's not just for the update, even for the select. Say I do a select once, and then there is no change as such, and then I do another select, I do a session.get, then Hibernate knows that it already has the data in its cache. It does not trigger a select again. So this level of caching is already there. Whether you configure it or not, Hibernate automatically provides this first level of cache. But then there is a second level of cache that we can implement as well. So why do we need the second level of cache? The second level of cache is needed because a session is not something that you would hold for a long period of time. As we've seen earlier, a session factory is something that's there for the entire life of the application, but a session is something that you want to open when you need to talk to the database and then close it as soon as you're done talking to the database. So whatever caching happens in the session will not be there for a long time. So if you're accessing a data that you had accessed in the earlier session, you would have to query the database if the session is already closed. So you would want another level of cache that goes beyond sessions. So we can implement the second level of cache, and that's what we're going to talk about in these tutorials. The second level of cache can be implemented in different ways. One is across different sessions in an application, so which addresses the problem of hey, I closed the session, now the cache is lost. So say you open sessions at different points in the application, what happens is that all those sessions will have individual caches, the first level caches, but then there is a second level of cache that applies across different sessions. So if it's not there in the first level of cache, you can it's likely that you'll find it in the second level of cache. Well, this is different sessions in a single application. You can have a cache across different applications if they're all using Hibernate and they're working on the same, the same set of data. You might feel the need to have a cache that goes across applications. So it's like different sessions in different applications. So this is again something that you can configure in Hibernate. And then the third thing is across clusters. So you have different applications deployed in different servers, and they are all talking to the same database, and they're interacting with the same data. You can have a Hibernate cache that supplies cache data for across all these applications. But however, you need to know that say you have you have another application that is not using Hibernate, that might result in problems because let's say for example you have saved some data in your cache. Now the other application which is not using Hibernate would not know that there is this data in the cache, and it might directly go talk to the database. So there could be this kind of a problem where an application which is not using Hibernate, is totally not aware of the cache, might still end up dirtying the data and updating the data in the database, and the cache might be invalid. So Apart from this, as far as you're configuring a single second level cache across applications, Hibernate is going to take care of it. Hibernate will know that there is an application that's written some data. Now, before a fetch happens, it automatically updates in the database so that the new fetch has the latest data. But if the fetch does not happen, Hibernate will intelligently keep it in the cache and try to minimize the trips to the database. So having said that, first let's have a look at the first level cache that we have in Hibernate. Again, I'll go back to the same main method that I've had. I'm opening a session and I'm beginning a transaction. So in this area, let me get a user object. So I'll say user details. I'll use a session.get. The session.get, of course, takes two parameters. One is the class and one is the ID. So I'll say user details dot class, and I'll pass the ID as 1. So I'm getting the user object with the ID as 1. Of course, I'll have to cast this because this returns me an object. Since I know that it's a user details object, I'm casting this here. Now I have got this user object. Now if I run this, let me clear this out. If I save and run this, you can see that there is a select query. So Hibernate is actually issuing a select query to fetch this user object. Now what happens if I assume that there's a lot of code in between, but here I will say user details user2 equals, I am getting the same user object here, but I'm casting it to a new to a new user details object. So what I'm saying here is that I'm getting this object once, okay, and then I'm getting the object not using this reference. I'm actually asking Hibernate to get from the database. I'm passing the same primary key. I'm saying, hey Hibernate, get me this object again. Now Hibernate knows that it's already got this object, so it doesn't really need to go to the database again. But let's see how many queries it runs this time. If I run this, there you go, it's still just one select. So the reason why it can get away with just one select is because Hibernate knows that between this statement and this statement, in between these two statements, there is no code that updates the user data. So what I mean by that is, okay, let's say for example I make this change here, user dot set username updated user. So I'm changing the user property here. Now let's see what happens. So here you can see it is doing a select and it's doing an update, but still it's not doing a select again. Now it's done an update. Now the database record has changed. Now why is it not doing a select for user 2? It has to get the updated value, right? Well, what happens is, since it's updated an object in the session, this object is already there. It's there in the cache. So again, there is no need for Hibernate to pull up this value. This user2 that Hibernate gets is actually the updated user object. So the point here is that Hibernate intelligently detects all these things. It does not go to the database unless it's actually required. So as long as you made the change in the Hibernate session, Hibernate knows that, hey, this is the object that I already have, so it does not go talk to the database. Now the things totally change when I'm opening a new session here. I'll use the same 2 lines of code. Okay, so I've closed this earlier session and I'm opening a new session. Let me call it differently also. Session 2 equals open session. Now I'll say session2.begin transaction. Now what I'll do is, by getting the user 2 object, instead of doing it in the earlier session, I'm going to do it in the new session. Okay, and after that I will close the session. Okay, so I have session 1, which pulls up user object, and I close it, and I have a session 2 here, which again pulls up this user object. It's the same user object, and then it closes the session. Now let's save and run this. Let's see how many queries this results in. So here you can see there are 2 queries. So what's happening is, since this session is closed, the cache is closed as well. So opening a new session will result in a new query. So this is the problem that we're going to address by using cache. Once we implement cache, which is the second level cache, both these sessions are going to talk to the second level cache, and once we have an object in the second level cache, the session 2 is not going to talk to the database as well. It's going to get it from the second level cache, and only when the object is not in the second level cache, it's only then that Hibernate goes and talks to the database. So this results in a lot of efficient use of resources. It's not going to talk to the database unless it's absolutely required.